Okay, so there is another way to solve these kinds of equations involving the modulus symbols. So please write this down. Equations like this can also be solved algebraically by squaring both sides. However, care must be taken because false roots can be found. So let's have a look at this. If we've got a question like this, I'm going to square both sides. Now, the reason why this works is if you think the modulus of A, say that it equals the modulus of B, well, I know both of those are going to be positive, so I can square both sides and it's going to give me the same answer. It's a useful way of being able to get rid of the modulus symbols. So, to use it in this way, we square both sides. So I'm going to have 2x plus 1 squared. Don't you dare put that as 4x squared plus 1 or I will hunt you down. And there we go, that's squared. So expand, rearrange it to make 0 on one side. You've got a quadratic to solve, so it does factorise, or you could use your calculator, but make sure you put the information down as to how you've solved that. So my recommendation would be to write out the quadratic formula with all the correct numbers in the correct places, and then you can just use your calculator to work those out. However, it does factorise to 5x minus 1 and x minus 3, so I know that x equals 1 over 5 or 3. So see, someone who's not savvy enough is just going to put those as your answers, but let's just check them both through substitution to make sure that they work. So let's put in a fifth to begin with. So I will have 2 fifths plus 1, and I want to know if that is the same as 2 minus 3 lots of a fifth. And I get, so 7 over 5, the modulus of 7 over 5 equals 7 over 5. So yes, that is definitely a solution. Brilliant. Let's put in 3. So I want to know if the modulus of 7 equals 2 minus 9 is negative 7. That is not correct. So that is not right. So there is only one solution. And like I said, if you use this squaring method, that's okay, but you do have to be really careful about checking your answer. I personally would use the other option, but you might like this one. Again, if I'd have drawn the graphs, I would have seen that there is only one solution there anyway. So I'd have expected it, and it would have been a lot easier just to solve 2x plus 1 equals 2 minus 3x, and I wouldn't have to go through solving that quadratic. But it is a valid method, and we are supposed to show you that it's true. And the reason why it is so useful is because we've got a modulus sign on both sides, then this is the best way to solve these. So what I would like you to do is use this method for the ones on the following page. So just to reiterate that first thing on that first one, what you're going to do is you're going to say, well, that means that x plus 2 squared equals 2x squared. Be careful with your brackets. I know that some of you would have probably just written that as 2x squared, but be very careful. Solve those, like expand, solve as a quadratic, and just double check your answers. So just have a go at those. Pause the video and then restart when you're ready for the answers. So here is the solution for the first one. Please mark your work. You can see I've done the checks at the end just in case. I could have done that by drawing the graphs in my calculator. Same for this one. And finally, C. Now, this just looked super weird to me. So I graphed them to see what was going on, and I ended up with this. And that's why we've ended up with some really strange solutions there. You just got a repeated root. But anyway, I just did that because I was interested.